Good answers for the first two up there, if you want to look those over. So it's like you were mixing up distances and times. Like the one was a 1 hour head start, I think. So like Bob gets the 1 hour head start and he goes for 16 miles per hour. So if he goes 1 hour at 16 miles per hour, he went 16 miles. So his head start was not 1 mile, it was 16 miles. Make sense?
Yeah.
Okay. Okay, do you guys have any questions on 1 and 2? Okay, so let's look at number 3 then. Same question we've looked at, just a slightly different scenario. It says, write an equation in slope-intercept form that shows the relationship between temperature and elevation. So let me just remind you, based on that, I think we would say that the y value would be a t, and the x value would be an e, because t would be the dependent variable, e would be the independent variable. So if I'm going to find my slope, I would do temperature 2 minus temperature 1 divided by elevation 2 minus elevation 1. So you're going to hope that you can make that connection back and see that's basically delta y over delta x. My T2 would be 11,000, or excuse me, my T2 would be 61 degrees Fahrenheit. My T1 would be 80. 11,200 would go with elevation 2. Elevation 1 would be 6,500. And then go ahead and doing the subtraction here, I'd get negative 1,900, or excuse me, negative 19 over, what would it be, 4,700? Okay. Okay, so that's my slope. I need to have a point as well. What point did you guys use? Any volunteers on which point you used? What did you have, Ava?
6,500.
Say it one more time. 80, 6,500. Okay, so she's got, I think you actually have it backwards.
Oh yeah, I did the right way.
6,500, 80. Okay. So 6,500, 80 would be my point. You could also use 11,200, 61. I'd set up my point slope, t minus 80 equals negative 19 over 4,700 times x minus 6,500. I need to do a distributive property and add the 80 over. Did anybody finish it all the way out and think you've got it? Anybody have the y-intercept? Joe, what do you got?
Y equals negative 19 over 4,700x plus 106.28.
106.28.
Yeah, I rounded it.
You said plus 106.28.
Yeah.
Okay. You guys agree with Joe? I mean, I think it's a reasonable conclusion. You guys have that exact number as well? Okay, awesome. Okay, so that's number 3. So there's 1, 2, 3 right there. Any questions at all? This will be your last chance to practice this before Thanksgiving break.
I didn't divide it out. I just left it as a fraction, the intercept.
The 106.28.
Yeah.
You're asking if that'd be okay?
Mm-hmm.
Definitely. Any other questions? Okay. All right, so then finally number 4. I want to give you guys hopefully a good reminder of a method for doing this. First of all, just read it like a story. Don't get too hung up on any of the numbers or any of the math stuff. Just read it like a story. Would it be fair if I summarized this whole story to say, Abby got a head start going to the mountain house. Candace tried to chase her down? That's basically it, right? So then I'm going to try to draw a picture of that. So I'm going to say that this is home. And Abby gets a head start. Abby's heading towards the mountain house or a potential catch-up point, one of the two. So this would be distance of Abby. Candace starts at home, and she tries to catch up to Abby. So there's distance of Candace. So how many miles head start did Abby get?
120 miles.
How'd you get that?
She was 3 hours ahead, so she's going 40 miles an hour, so if you multiply 2 by 40.
Yep, that's exactly right. So 120-mile head start. So then what we had to do is we have to write an equation about this that's true, a relationship that's true. So I'm thinking that it would be dA plus 120 equals dC. Shorter distance plus the head start gives me the longer distance. Okay, so then distance of Abby would simply be rate times time. What was Abby's rate?
It's 40 miles per hour.
Yep, so 40t plus 120. And what would we replace dC with? 70t. Yep. So I would subtract the 40t over. That would give me 120 is equal to 30t. So how many hours would it take for her to catch up? It would be 4 hours. So we got to decide, does Candace have enough time to actually catch her? Does 4 hours? 4 hours could be too long? So you think that she will catch her on the road?
No, she
No, she won't catch her.
Okay, why not?
I figured it out because I figured out how much left Abby has of her journey. And
Okay.
I did that because we know the total journey is 190 miles.
Yep.
And so I subtracted 120 from 190, and that's 70 miles left to the distance. And then I used her rate and multiplied that by the distance.
Sure.
And then I figured out that she only had 1.75 hours left. And
Okay.
her sister has to have a full 4 hours to get to the house.
Okay, yeah.
So that's how I figured out that they're not.
Yeah. The 1.5 whatever is less than 4. Yeah. Callie, did you have something you wanted to add to that?
Well, I was thinking so I didn't do like all the complete algebraic steps, but
Yeah.
if you added 40 to 120, that'd be 160.
Wait a minute. Why did you add 40 to 120?
Because if that's like one more hour. I don't know what I'm doing. Never mind.
No, I wasn't saying that. I just wasn't sure why you added 40 to 120.
Yeah, because that's like 1 hour more, like of going 10 miles per hour.
Oh, okay. So her head start was 120, and then you added another hour's worth of travel.
Yeah. And
Okay.
That'd be 160, and that'd be 4 hours. And that's 190. I think I just need more algebraic steps.
Okay. Okay. Well, maybe you could think about it like this. If it would take Candace 4 hours, we could say distance of Candace would be 70 times 4, right? 70 miles an hour times 4 hours. So Candace would need to travel 280 miles to catch up to Abby. And weren't they already there at 190? So she would have to go past the mountain house to catch her. So by the time she's caught her, they were already at the mountain house. So I don't think she caught her on the road. So I think the overall answer to this is no. She did not. Okay. So again, I'm hoping that that's starting to round into shape for you. If it's not, the good news is we still have time on the other side of Thanksgiving to help you practice that some more. So we will do that. The rest of our class period is for you guys to be working on your project. So I know